Well, hello everyone and welcome back. So we're going to start exactly where we left off. And what I've done actually is more or less to go back to the last video that we had, which was about role-based access control. And what I've done right now is actually to commit this to GitHub, and I've committed this under um, this branch. So what I'm also probably going to do is maybe update the README to reflect the changes we've made. So I can come up here and maybe add a new section, and I can call this hierarchical RBAC implementation in Golang, and this is going to be under like you can see right here, RBAC. And yeah, so if you never check, if not checked it out yet, I would actually advise you to do so, because I think there's a lot that I tried to cover here. And again, like I said, I have a plan in the future. I am currently actually developing a library for hierarchical role-based access control, and this is probably, I'm implementing this first in Rust, and afterwards I will implement this in Go. The idea would be to have a library more or less that you could use if you are developing an application that has anything at all to do with managing user roles and permissions, and you could actually just use this library, and it's going to be more or less kind of like a wrapper around your authentication logic. The point is, this would help you more or less easily manage the position, basically be able to assign each user roles, and assign them to a given scope, and scope their permissions more or less, and kind of like have like a godlike administrative view over every user you have in your application, and it's going to be like really pretty easy to work with. And of course, I will keep you posted when this is of course done. So yep. So but what I will do now is to basically, maybe I'll probably just commit this, and maybe a commit message. I can say added a new section in the README for HR back, something like this. And I'm gonna push this. And yes, of course, I need to, because I just created this, I'm just gonna copy this and paste it, and that should be fine. And now I can create a new branch, like we said, and I can call this comms, because that's what we have here. And now let's start. So what I would want to do more or less is to show you a little bit how you could work with forms and form data. And also, I have maybe a little bit about WebSockets, because if you know, or if you've been following me in my channel, I've covered a lot about WebSockets, like some tips and tricks, not just WebSockets, but actually like utilizing, say, good channels, to share data around certain aspects of your project. But I will still try to show something. But of course, in the end, I'm going to attach the links to those much more detailed videos about WebSockets in Go, and you can actually check this out. This would give you a much more deeper sense of what we are doing here. So with forms, probably what I'm gonna do more or less is to show you how we can actually do this with first, say, um, raw, like HTTP, nice HTTP package without gene, and we can actually like use actual HTML forms, and you can see how you could do this. For example, if you just, I really want to show you this independent of the framework, because I think problem that we have these days is most people really just focus on frameworks without understanding the basics themselves, and I really think this sucks a lot. And so that's why I would really want to show you this with the net HTTP pack, just so you understand that independent of the framework you choose to work in with in the end, you might of course decide not to want to work with Go in your career. That's also totally fine. But I would really want you to understand the underlying principles, so you can, if you have, you're in a scenario where you actually have to work with the net HTTP package, you can completely do this with independent of any framework. So that's the point. So I'm going to comment this out so that we can actually make our implementation here with the net HTTP package. So to get started, what I will do is going to be pretty straightforward. I will create a struct that's going to represent. So let's just imagine that we are creating a form where users can provide, say, their name and then maybe leave us a message or something. And maybe what we can do for a start would be I would like to maybe come to the root and create a file. I can just call this form.html. That's really fine for me. And so I need to put this. Yes, thank you. Awesome. And now, of course, HTML, head, title, and I can call this contact form, something like this. And yep, then maybe in the body, I would maybe add h1 and I can say um, contact us. Please don't mind my shabby way of writing HTML. This is really not my strongest suit. So, and so our form, the action is going to would have an endpoint, say submit. This is where our form would go when the user, of course, clicks submit button. So, and I would like to add a method, and it's going to be post. Of course, with raw HTML, more or less, you have only option of using post and get. Every other thing you have to handle with just these two methods if you are working with raw HTML, but that's not really the point of what we're doing here today. So I can add a label and maybe I'll say for a name because I would like you to provide a name. And here I can provide name this way. And now I add an input field. So it's going to be a text. The ID is going to be name because we have this up there. And the name of this I'm just going to call it name, and we'll just maybe do some validation. I can say this will be required. So if you try to provide this or without giving us providing more or less this, is going to error out. And of course I need to close this up this way. And maybe yes, I can actually just do same for the other fields that we need, just to make it much faster. I don't want us to waste time on unimportant things. So here would be email, form for email, and I can copy this name would be email and ID will be email. And this one would can say message like this, and I can copy this again. Name would be message, ID will be message, like this. And maybe what I can also do, let me quickly think about it. Okay, so up here, I can maybe provide a line break. I think I have to also, of course, close it up this way, and maybe I'll put two of it. So we have it's nicely spaced. I don't want to write any CSS, please. I don't want to waste our time actually doing this. And so I just put this line breaks. That should be fine. And maybe actually I can change this to text area. So the ID would still be message. Um, yep, the name will still be message, and of course I can remove this type because we don't need this anymore. And I can maybe I can do it this way. Come on. And maybe now I can provide more info. So I can say rows, maybe 4 rows, something like this. It's not that serious actually. And then I would need maybe lastly an input field. And this is going to be of submit. And I'm going to just give it a value of submit as well. So what I will quickly also, of course, show you what this will look like in the end in the browser. But the point is that we would want to, oh, please, this should be submit, not submit. The point is that we have a form where you could provide the name and email and the message, and we should be able to handle this in our application. That's really what we want to do. So now I can come in here and set this up. So I can create a struct down here, and I can call it form data. and it should have all the fields that we specify. So we say name should be of type string, we have email of type string, and we have message also of type string. And now what I can quickly do already is to set up our server. So I can create my main method this way. Of course, I create our main method this way, and now I need the HTTP package, HTTP dot handle func, this one. And of course, I need to provide the path and everything. So it's going to go to, I would actually create two endpoints. So one would be to show the form to the user, and the second, of course, would be to handle the submit. So when you go to the slash, you're just going to see the form, but the submit action will of course forward the form to this endpoint. And what we now need to do more or less at this endpoint would be to process the form, extract the form values we need, and then of course do whatever it is we would want to do. So to that effect, I'm going to maybe come up here, create two functions. So I can call this one maybe render template. And remember, the signature has to be of, it needs to have a response writer and of course a request. So, and the convention normally, some people mostly use W and R. And so this will be HTTP that's response writer, this one. And of course would be a pointer to HTTP requests like this. And what I can actually do is maybe copy this and duplicate it. And I can maybe call this submit handler. So this one would be our render templates, and this would be our submit handler like this. So when we visit these two endpoints, you should be able to, of course, forward our request here. But of course, this is not enough to, of course, start our server. And now maybe I give a message to the user and say we want to serve this our server at, I can say server is being served on, maybe I say on, say HTTP colon localhost, and let's say 8080, and maybe that should be enough. And now I can actually serve the server by using HTTP, that's listen and serve. And of course, I'm going to serve this at 8080. And for this, I'm just going to provide the nil for now. So this should be sufficient. So if we open our terminal and run main.go, we should be able to see our server come up. And of course, if we can already call this, and we can go to localhost 8080. And of course, nothing is really happening now, because if we put some message here and say hello from the render, whatever, something like this, and I restart this again, clear this out and try to start this again. Now, of course, we get this printed out here. Nothing is being returned to the user anyways. So I can close this up and of course do same here. So we can have space to start working. So the first thing, of course, I would want to do is to handle the form rendering. So this function basically. And what I'm going to do is just going to be pretty straightforward. I will use the templates package that comes with Go. So I can already handle I will try to pass the form. So I can say this way, I use this request, of course, to pass form, and it returns an error, and then I need to handle this error. So if this is not new, if this is not new, maybe I can just do some HTTP error. Where is the function? Okay, this one. And of course, I pass my response writer, and then I can, of course, maybe pass the error that's we provided, and then I need to provide the status code. I can still get this from HTTP package, and I can maybe say bad request, this one. So if you're not able to pass the form that is being submitted, we will just throw this error. That's basically it. And other than that, now we can actually get our values. I can say name. At this point, we are able to pass our form. So this would be from form value, and the key would be name. And I'm just gonna, because I'm lazy to type today, I can just duplicate this 3 times. And this will be our, come on, go away, email and message. So this would be email and this will be message. And now I can maybe say requests would be, and I can of course create more or less populate my form data like this. So name would be name, email will be email, and message will be message like this. And now I can, of course, at this point, our work is done because we're able to actually get the request, the payload more or less that we are supposed to get in the first place. And now we can do with it as we please. Maybe, I don't know, we can have a function down here called, maybe, let's just say write to DB, something like this. So something like this. So it takes a data, which is of course of time form data, and doesn't do much for us now. It's only maybe we just print this, something like this, and we print data. Say data has been written to the database, and something like this, and maybe we return and oh, that's this model already enough. So we can say write to DB and we'll pass the request like this. And what else can we do? I think that's actually it for this endpoint. So I think that's already sufficient. So what I can already do is maybe start the server, go run main.go. And before we use this, I can also maybe, if we don't want to go to the browser, but of course we will go to the browser, but I can also use our HTTP file over here, if you remember. And I can also use it to make a how is it called, a post request. But in this case, of course, we will still be passing our form, our content type will still be of type form URL encoded, more or less. So I can call this form submission, and it's gonna be a post, and this it should go to HTTP localhost this guy. Thank you. And of course, we need to, of course, provide the HTTP version, more or less. And now I can provide content type. Content type should be application this guy. And I think that's actually all we need. And now we just provide what we need to provide. So I can say name to Ni. You can also put this in different lines, doesn't matter. Email, I can say email at example.com. And what is wrong with you? Don't help me, thank you, go away. And of course I can pass my message this way, some come on, some boring message, whatever, something like this. And this should go to the submit endpoint, so we can try to call this and we get an okay. But we don't, of course, let's see if I don't think this actually saved. So I'm gonna restart this server and then try it one more time. So now this server should be up, and so let's do that one more time. Come back here, HTTP, and then we'll make our request again. So why am I not getting anything? That is weird. So we go back here and submit. We are actually calling this endpoint, and actually nothing is happening for now. So I can maybe actually just come over here and just go to the root like this, and send the request again. And now you see our form is actually being processed down here. And that's really more or less what we want to do. And in the end, of course, we're still going to go to the browser to use this to do this form HTML. That's totally fine. But of course, it's going to behave exactly as the same. And we can actually just go ahead and try it out. There's no harm in trying, guys. So I will head over to the browser and then we can test this right away. But before we go to the browser, I would of course like to first render this template on the browser so you can actually see it. And of course, right now we are not doing that. But what I would want to do is that when you visit this endpoint in the browser, you would already see our form, this form HTML over here. And so actually what I would do is this should not be render HTML. So I'm just going to copy this. As you can already tell, we made a mistake to put it in the wrong function, but that's totally fine. So this should be here actually. And now we need to handle or more or less render the form. So I can use the built-in the HTML template package that comes with Go to pass our file. So I'll use the pass files function, and I'm just going to provide just one simple form here. That's totally fine. So we call it form.html, and if we hover over this, we get two things back. So we get our template or an error. So I can sort tmpl for template and error, and we can of course handle our error. I'm just going to copy this guy. Just come over here and say if this guy is not equal to nil. Now I would like to say maybe internal server error. Internal server error, something like this. We will handle this later. I will leave it to you more or less to handle. Let's focus on what we want to do. And when we have our template, what I want to do now is, of course, to render the template. So I can, it's quite simple. I can call the execute method on the templates. And of course, I need to pass an IO writer, which of course we can get from our response writer. So I'll simply pass this in here. And for data, I'm just going to pass nil for now. So this execute again should return just an error. So we handle this, of course. So we say if error, and this is error is not equal to nil, and we handle this again. I'm probably also just going to copy this guy and put it in here. And if everything goes well, if we get to this point, then our user would be happy because right now they will be seeing our nice templates. So I think that's totally fine. So let's check out if everything is hooked. So this should be here and then submit is here. So now I'm just going to move over to the browser so we can test it out if everything is working fine. And then we can conclude with this and then move over to working with our Gene framework and see how this comes together. So now we are on the browser and I just visited the URL as you can see over here, and over here we have our form. And now I can just put some information here and just, I don't know, put whatever here, and I click submit, and we get this nice message from the server. So you can see our server is correctly handling this load. And of course, what I've actually done is just to go and add this just one single line, so that's our backend actually writes this message back to the front when the form is properly submitted. But what you can see, the code then is that it goes to our submit endpoint, and when, of course, this is the submit action. So if we try this again, of course, put some whatever we want to put here and submit, that's also totally fine. So that's really pretty straightforward if you ask me. But now let's head over to the code editor. I'll just show you because I also noticed I made some typographical errors, and I will just show you that when I head over to the code editor right now. So we are back in the code editor, and the typos I was talking about that I made was here actually had like form.html, and I'm probably think maybe you saw it actually, but yeah, so I had to correct that. And the only thing again was that I'm writing this message to the front end. So initially we had this message like hello from the server or whatever, but I just replaced it with this fprintf, and then this is the message that we were getting from the browser. So but what you can already tell is right now, if I restart this server, for example, and then I visit the web page one more time, let me try to visit the web page one more time. So when of course, if I just go to submit and then I click submit, the form is practically going to be empty. So it means if I click submit, our backend is just going to get nothing here, as you can see over here. So again, this is where you can do some more validation here. You could now say, okay, if this is an empty string, blah, blah, blah. And then, but I'm going to leave that to you because of course you're more than capable of testing out that step in our development process. So that would be it with of course validating form. So if of course you can already think if you work in such scenarios whereby you have your front end team and then they are building this app and somehow they are submitting like raw forms, or they asked you to provide an endpoint where they can submit raw forms. If you're working with net HTTP package, you can already see how you can confidently and of course handle this without any problems. So that should not be a problem for you at all. So now I'm gonna create a file in the root and I can call this form and maybe hyphen net http dot go, something like this. And the point of this is that I would like to, this would be package main. The point of this is that I would like to move this logic out of here so we can continue what we are doing. So I'm gonna copy this, put it in here, and I can call this main2 so it doesn't conflict, because you can have the same package, the same function name within the same package. You can already tell. And of course, that's why we're already getting this error, because it said you're already declaring this block. So I'll put this in this new file just so you can have this for reference. And then I'm just going to remove all of this because I want us to continue with what we've been doing until now. So I'm going to comment our code actually and comment all of this. And then I remove this completely. And now we should be back to where we started. So I can close this up and then we can focus on what we've been doing so far. So this is now where we started. So now what we would want to do more or less would be to try to see if we can still do this with Gene. And trust me, this is pretty straightforward, pretty straightforward. So to test that out, I'm just going to maybe go to, let's go to handlers. We got auth. I'm just going to add a new folder here and I can call this miss. And in here, I would create a file and can call this form.go. So this is what we're going to use to test out our form. I'm just going to keep it quite straightforward. I don't want our videos to be really, really long so that you get bored at some point. I wouldn't want you to be bored actually. So I don't need this anymore. I can close this off, of course, and this one. So let me go, this one go. And now I can actually just come here and copy this. I want to copy this and bring it in here. So this, sorry, this would be, would use the same form more or less. The only difference now is instead of, because now we would be working with the Gene framework. So now what I will try to do is to, of course, provide some more information about our struct. And I'm just, as simply as this, I'm just going to provide the values for our variables in the struct so that it could be properly extracted from our form. So if I provide the name like this for all of our structs, we would so easily handle the forms in like working with Gene. It's much more easier, as you can see, of course, because there has been a lot of abstraction that has happened under the hood. But of course, this is all we need to let our structs handle form values if you would want to submit forms to us. If we provide an endpoint that is being provided using the Gene framework, as simple as this. And now I would like to create our handler. So I can call this form handler like we did before. And of course, now instead of taking our response writer as request as input argument, of course, it's now just going to take the Gene context. So provide our Gene context as the argument, of course, a pointer to our Gene context. And now we go away and now provide the body of a function. It's actually really straightforward. And now the only thing we need to do is to create, I can call this request, and this would be of type form data. And now all I need to do is bind the incoming request to this. So I can say c.bind, and of course I provide a reference to our request. And of course, I can see what we get. So we get an error, and we can undo this error. Of course, we say if this error is not new. But I just want to show you how easy actually is if you're working with Gene. So if this error is not new, maybe we can now, of course, do our JSON, and we can provide a HTTP status code and status bad request. And I might like to provide some more info, so I can use the just header like this, and I provide some miss, and I can say error. This error will be what we get from here, this guy. And so that's keeping it as simple as possible. So, but at this point, we have access to this. We don't need to do, if you remember what we did here, we don't need to individually extract the values. This way, we don't need to do all of that. If our code gets to line 22, everything is good. Just just take my word for it, basically. And of course, to verify, maybe what I can do at this point is just to send this again back to the user. So I can use HTTP packet again to provide my status code. I can say status OK like this. And now I need to provide a body. Again, I would do like what we did up there initially. And I can just provide all of this again. I can say name. So it'll be request.name like this. Email, and of course, last but not the least, provide our message. And this would of course come from our message like this, as simple as this. And this is all the code more or less we need to do exactly what we did here. But again, just like we said, there's a lot of abstraction of course happening on the hood if you're working with a framework. And I really would advise, of course, that at some point to not always go looking for frameworks, to be honest, but to always try to understand at least how the whole process would work within a given language. And I also have a tutorial that I'm working on, which of course tries to develop a server in Rust, but without any of the like the popular frameworks in Rust, like say Axis Web or Echo or whatever. I try to use like the native packages that come shipped with Rust to do this, because I really think this is one way that you would really understand what's happening under the hood. So now you can understand, for example, what is within the gene context. If you're working with the net HTTP package, each of your functions always take like the response writer and the request as arguments. But if you're working with gene, you would realize that your handlers only take one argument, which is the gene context. What is in the gene context? If you look in the gene context, you see you have here again the response writer and the request. So you can already begin to understand that the gene context more or less wraps all these other things together. But if you've only worked with gene, for example, you would not even understand what this means to begin with. So that I would always advise that at some point leave frameworks, to be honest, and try to understand how things really work under the hood. Anyways, that's all we actually need to have this working. And now, of course, we can really go to our API and hook this up. We don't have a miss endpoint. I'm just going to create a new file here. I can call this miss.go. It doesn't really matter. And I'm lazy. I'm just going to copy everything here and put it in our miss endpoint. But now I can call this add maybe miss routes like this. Miss routes, and it's going to be at /miss. And then I'm just going to say form, some like this. And now I'll need to change my handler, of course. Form handler like this. And then, sorry, I don't need to invoke the function actually. So it should be fine this way. And now I need to go to API and of course add this guy. That's all. Version, that's all we need. So if we run our server one more time, so go run main.go. And now we can again try to use our what we used over here from this guy to test our server. So now it is up, and then if you look down here, you would see the URL. I'm just going to copy this because I'm lazy to type. Sorry, and I'm just gonna provide that here. I need to remove one, and now we can send our request one more time, and you see we get our response back. So the exact same thing we sent in was also exactly what we got back. And so that's really one way we can, of course, work with we can work with forms with Gene. And I'm really hoping that this has been insightful for you. Of course, if you've never had to do this in, or if you've been wondering if you how it's done, or more or less try to be sure if the way you are currently doing it is one possible way that it could be done, I think this would more or less clear that for you already. And so that's it. The next thing I would probably want to show you again in this tutorial would be quite briefly, how we can provide like a WebSocket endpoint. And it's going to be like really, really pretty straightforward. And again, like I said, I'm going to provide the links to previous numerous other tutorials I've made in the past, how you could work with WebSockets and Go, not just WebSockets, but like juice it up a little bit and add some flavors, working with channels and the rest. I will leave the link in the description so you can revisit this, because those are much more detailed. But what I'm gonna do is just maybe copy a lot of code from what we already did in the past, put it in here, explain what's going on, and then we can test it out to see what's happening. So let's do that right away. So if you remember the last video that I uploaded where I was trying to explain the difference between working WebSockets and event sources, more or less like server-sent events, I tried to explain that, of course, with WebSockets you have bi-directional communication, but with server-sent events you have only a unidirectional communication going only from the server to the client. And again, I think that's a nice video you should check out if you are considering, or if you have a scenario where you don't really need the full bi-directional communication. You just want your backend to constantly send that at your front end. I would point you to that video also, so you can really, really check it out. I think it's a really cool tutorial to have. But what I can quickly do also is maybe this maze folder we have here, I can create a new file and can call this events.go and package maze, and I need to define a handler here. I can call this events handler. And again, like we already said, it takes a pointer to the gene context as an argument. And now, of course, a WebSocket endpoint is more or less quite similar to an HTTP endpoint. The only difference is that the request actually gets upgraded to a WebSocket endpoint. That's basically what happens. And to do that, we can simply come up here to create our upgrader. I can, of course, I want quick way we can actually do this to maybe is to, I can create a variable here, and in here I would maybe do it this way. I would like to create just one variable called upgrader, so I can call this upgrader like this. And I would need this to come from, of course I'll need this from Gorilla WebSockets. So I hope this helps me out. So I say WebSockets dot upgrader. It doesn't help me, so I need to import this. So I'm just gonna, that's totally fine. So let's do this way. I think it's at github.com/gorilla slash WebSockets like this. And I hope this is, you can help me out here. I think my IntelliSense is quite slow today. I don't have this installed, so I need to start my server and go mod tidy if I don't have already installed, and I think it's installed now. And yes, of course, I don't need this anymore because I'm declaring a variable this way. And I need to provide a couple of arguments in here, and just few actually are what I would want to provide, very few. So I would need to provide a read buffer size, and I would like to leave it as 10 MB. So I can say 1024 multiplied by 1024 multiplied by 1024. I'm just going to copy this. So my read buffer size would be this size. My write buffer size would also be this size. And the next thing I would want to do, of course, would be to add a function that checks the origin. You can always hover over structs like this to see what's possible, where you can configure. I'm not interested in all of this for now. So the only thing I would want to do actually is this check origin function. I'm probably just going to copy the signature here and implement it, because again, I'm lazy. And of course, I need to, this is part of a struct, so I have to be this way. And for now, I'm not really checking the origin. I'm just gonna return true. That's fine. So it's all origins actually will pass more or less. But the point is that you have the option to use this to specify which origins actually gets passed, so that you only, of course, have this visible or available where you would want it available. Just that. And now, so in here, I would like to use this upgrader, so I can call this upgrader dot upgrade. And now I need to pass my writer. Again, you see the writer in Gene context is exactly the same as the response writer that you get from the init HTTP package. So what it means is that, of course, the every framework you have would always wrap around the packages that we are shipped within the language. Again, this is really important. I think this is really important. You always make it as a duty to check it out, what's comes shipped with the package. And then we have here our HTTP request, which again, more or less, if you look over here, you will see that up until this part, this have a function signature similar to what we actually defined when we were working with the net HTTP package, but that's totally fine. So now I've provided this. I'll need to provide request. And now for response header, I'm just going to leave this as nil for now. And then let's see what comes of this. So we have our connection and an error. So say con error, and we need to handle our error. So we say if this error is not equal to nil. Of course, at this point, we would like to return back to the user. So say cjson http dot let's say it's our fault, internet server error. We don't want to waste so much time on this. Come on. So we provide the error to the user, error like this, and that's already fine. And of course, we need to return, otherwise the code is going to continue executing. Okay, and so if we have our connection, the next thing we would now need to do more or less would be to, of course, promote this so that a user can connect with us. So like I said initially, I will leave a link to a video that I did in the past where I explained in detail how you could work with WebSockets in Go. But for the sake of this topic in our course, I will try to give more or less an abridged version. Of course, it should still be functional, but the point is that you would, of course, need to modify it in some way to be able to carry the kind of workload you would want to process with this. So again, like yeah, I'm gonna move forward actually to start working. So I would need to define sorry, I would need to define two structs. One would be to define what the client would look like, and the other would be to define a struct that's going to take care of our actual payload. So I'm just going to go ahead and define those. So I would have your clients. Of course, it's a struct, and the clients, I would like it to have just very few attributes. I'm keeping it as simple as possible. So every client should have an ID, and every client, of course, should have a connection. So this is going to be of type WebSocket connection. This one, and the last thing every client should have would be a send attribute, which is basically going to be a channel to a slice of bytes. So this would be a channel, and right, so this more or less it would help us, of course, to pass messages around more or less. And I would define another struct, and this would be my actual payload. I would just call this event. Again, it's going to be a struct. I'll keep it as simple as possible. So I have timestamp. So this for now, I'm just going to make this a string. I would have maybe I say some I don't know, let's say some topic will be a string, and then would have a value which is probably going to be let's say int for now. And I think this is more or less enough. This is enough. So that's all we need. And apart from this structure that we've defined, I would like to define three functions. So I would need I will just go ahead and define those. So maybe I'll put some comments first. I will need a function to write into some events channel. So this function is basically going to help me to simulate some events data. And I can actually go ahead and define this. So I can call this generate events, something like this. And of course, this function will more or less run infinitely actually. So so it's going to take a channel which is going to be the data type that we will pass in this channel will be of type event. And what this function is basically going to do for us is going to be a for loop, actually, an infinite for loop. And the only thing it would do more or less is to generate an event type and then write it into the channel. That's really all it's going to do. So this will be of course, I need to give this a name. I can call this event channel. So what it's actually going to do is basically to write into this channel. That's all it's going to do. Of course, I've spelled that wrongly, but that's also fine. I can change that right away. So it's just going to write into this guy and it will write an event. So now I just need to provide, and of course, before I forget, I would like to sleep after each write. So for probably 2 seconds. So I'll sleep for 2 seconds after each write. And of course, I need to populate this part. So my times, what is the error? Why am I not getting IntelliSense again? Timestamp would be time dot now. I'll just convert this to string. I'm keeping this as simple as possible. And I will say maybe my topic so I created this function that I could use to generate random strings. I also explained this in the event source tutorial, but I will also add the link so you can check this out. But basically, just a function that takes that more or less generates random strings. That's really it, because I just want to generate random topics here. I could actually, or maybe I actually don't need this. That's totally fine. I'm just going to hard code this anyways. I can call this maybe I give it a name, something like I don't know, let's say Berlin slash maybe I say location one, something like this. And then I add some maybe machine 001 and then maybe some I can consider this temperature sensor. I call this temp one, something like this. And then I provide a value. So for value, I'm just going to generate more or less random numbers. I think that should be more or less enough. So rand.int, and of course I need to generate integers, and I can make this. So I would need to generate numbers between 0 to 100, and maybe I can also make this interesting by making this turning this into a string, and then of course formatting this to become a string more or less. So I can actually maybe just take this out and use the format package sprint f like this, and now I can provide maybe this would be integer like this, and then maybe I now provide c for temperature and something like this actually. So that's this would say this is maybe I don't know 10 degrees whatever, and yeah, so this because we are providing a temperature, we more or less assuming that we are consuming like a temperature values coming from a sensor from machine 001 at location 1 in Berlin whatever, and we cannot call maybe even annotate it to our organization. So this is org1 whatever, something like this. That's already fine for me. And so this is going to constantly generate our events for us more or less. So the next function I would like to create more or less would be a function that's going to of course consume the messages that's coming from the events channel. So it's going to consume the messages and then write them to the clients that are connected. And so maybe I add a function here. some comments rather, function to consume events from event channel, something like this. And I can call it consume events. And of course, it's still going to take the same channel because we are reading from the same channel. Event chan, well, like this. And it's also actually going to be much similar to this one. But yeah, it's just going to be the reverse. But of course, it's going to be a infinite for loop. So it's going to read out an event, which is going to come from our event channel. Sorry. It's going to come from our event channel. Then we use our select statements to actually decide what should happen when we are processing this message. So the first case I would like to consider. So I would also need to create a channel up here that we can use to, of course, manage connection and disconnection of clients and stuff like that. And but I can just maybe apart from this, I can also add this here. I can say close channel. This is going to be a channel and the type is going to be of type bool. So and now I can say when a client disconnects, so I can call this close chan. When this is the case, we simply return. But otherwise, come on. Otherwise, it's gonna have the default thing is basically gonna do for us is basically read this event and then write it into our message channel. So I can call this JSON bytes, which will be because I will try to marshal the data that we get from our channel. So JSON.marshal, and of course I pass my event, and my IntelliSense is quite slow. So once we have our message, so of course we have our event here, and then we marshal it because we need this as bytes. And when we have this, we would need to write this into another channel. So I can add another one here. I can call this MSG chan. It's going to be channel again of let's think a little bit about it. Um, yes, actually, we would use the one we had over here actually. So I can copy this because this is going to be looks more or less something like this. So and was because of course this is bytes, and now we can actually just simply write this into the message channel. So I can say message chan, and we simply write into it. That's all we have to do. So this function more or less generates random events for us and writes into this event channel. This function listens to the events channel, fetches messages, and writes it into the message channel. I'm guessing that's straightforward for you more or less. But we need channels here to more or less coordinate the communication between the different parts of our application. That's definitely just what we're doing. In a real life application, of course, we would not be needing to generate this. This could come from anywhere. It could come from, let's say, a Postgres DB events, or let's say you're even using like a cloud-based NoSQL database like DynamoDB. You could be listening to that database streams. It could come from anywhere actually. And so, but of course, we don't have that in our tutorial. So basically, we are just simulating this. That's just all we are doing here. Normally, we would only care about consuming the messages and then, of course, broadcasting them to your connected clients. But I'm hoping that's as clear as possible. So let's proceed. So I need a third function, like we said, and I can say a function to manage connections. That's what this is really going to do for us. So I can call this manage cons, and now it's actually, so what is it going to do for us? So basically it's going to um of course take messages from this message channel, and when it gets this message, of course it will need to broadcast this to all our connected clients. So it's going to take this, and of course I need a client, client like this, and then because we need to know what's to do with the message once we have it. Okay, so again, I'm going to need an infinite loop here. And so within this loop, I'm going to use a select statement to handle the message that would be getting out of our message channel. So I have a case for message, and I also need an OK attribute because this is going to become, we'll be reading this from our, actually, did I give the, yes, message chan. Are we reading? No, nope. No, actually, we don't. Do we really need this here? I actually don't think we do. So I'm just actually going to take this one out because we're going to, let's just, I think this function is basically actually just going to focus on our connections. So I have our client that send. So if I hover over this, for example, this would, of course, as you can see over here, this is what we set up there, the channel that we are reading from more or less. So we have this already, only need to hook this one up to the attribute we have over here in our client, and that would already be available to us here. Yeah, that's what we're trying to do. So again, we get two things back: our actual message, which of course should be a slice of bytes, and an OK attribute that tells if everything went well or not. And of course, at this point, we need to handle this. So if this is not OK for some reason, and now I would probably just maybe write an empty message into to the client, something like that, and then I return. So I'm just gonna um, maybe look to the client, use the con attribute, write message. And the message I'll write, of course, would be to close the message. So basically, if you disconnect or something, then I'll just do this WebSocket dot close message, and I'm gonna write an empty byte of slice, basically empty slice of bytes. Sorry, the other way around. And I'm going to write something like this, and I actually need to handle this so I can also say, oh, let's handle that. That's totally fine. So if this error is not equal to nil, we can just log something to the user for now. We could say we are not able to close the connection, something like this, I don't know. And then of course we'll need to return. So, but other than that, if everything, if we don't, if it's actually okay, which means we don't have any error, more or less. No, actually need to put this here. No, I need to put this here. So if this is not okay, either way, it's gonna return back to the user. But otherwise, I will need to write the message that we actually got. So write message, and I'm just going to, of course, this would be WebSocket the text message, and we write the message like this. And we also need to handle this because it's gonna, we're also gonna get an error back. So we handle this, of course, separately. So if this error is not equal to nil, for now I'm just also gonna log a message and say we are unable to write message um into the channel, something like this. This should be sufficient. But of course, if that is not the case, the default thing would want to do would be to just continue. So if nothing is happening, of course, we don't want to do anything at all. That's just it. And I think that's all the functions we actually need to create. So what we're just going to do now is to go ahead and set up everything that we need. So after creating our client this way, after we've upgraded the client's request, I'm just going to go ahead and create the channel. So we need an event channel, and I'm going to use the make function to create that. So it's going to be of type event, like we said. I need a maybe close channel. This is going to help us close connections when a user disconnects. So it's going to be of that boolean, and then we need our message channel. Of course, you can already guess this is going to be a slice of bytes, more or less. That'll be the type that will be handled in our channel. So I'll make this bytes like this, and that's more or less all we need. So the first thing, of course, I would want to do now is to call the function that's generating our events for us. But I would like to call this on dispatch this with different go routine. So I call it this way, and so I can simply pass, if I hover over this and we need to pass the events channel, and I can just pass this in like this, that's fine. And the next thing, of course, would be I would need to, of course, manage connections, and I can again call this function manage connections. So we need to provide a client, and of course now we need to instantiate our client here. So using the client structure created up there. So this should be our client, and I pass that in here, our client. And the last function, of course, would be the consume events. So consume events. So we need to pass the events channel and of course the close channel. Something like this. What is the problem? Yeah, of course, it needs a third argument here, which is our message channel, like this. And now, so what I would just want to do, the last thing I would more or less do would be to basically have a infinite for loop as well here that reads our messages from and more or less decides on what we want to do with the message. Of course, maybe broadcast them, whatever, but yeah, so I can create an infinite function here as well, and it's simply going to read our messages from the connection that we've created, more or less, and we should get back two three things. So the message type, the bytes, which would of course be our message, and then some error. So I don't really care about this message type. So I need my message and the error of well, because we need to handle the error. And so what I can do with the error is if this error is not nil, if this is not nil, then I'm probably just gonna close the connection. And of course, I think this also gives us an error back, so I can handle this, or maybe I'll leave this for you to handle. I'll leave this for you to handle, and then afterwards, I simply just break the for loop here. But other than that, if there is no error, I'm simply just going to write this into the client um, like this, and I write in the message. That's actually all we need. And now, of course, we now need to properly populate our ID, our client, more or less. And of course, this is the easy part. It's not that hard. So for the ID, I'm just gonna use a UUID. So UUID, that's must, and I need call the new method to, of course, create this for me, and then I'm passing a nil here. I don't really want to pay attention to this, and now I need to convert this to a string because I need a string in the end. And then of course connection will be the one we'll create it up there, and then our send, of course, will be our message channel. And that's actually all the code we need to set this up. So again, remember, I'm putting this in this way so you understand what we are doing. So again, we said this is not really necessary, but this is just to generate our, I can say, random events, something like this. And then this manages our client connections. And this one finally consumes our events and writes to our message channel. And now all we now need to do here more or less is to read out of the channel and simply broadcast it. Again, like I said, I'm going to add a link to the much more detailed tutorial that I did with regards to working with WebSockets in Go, and then you can of course compare, because there are, trust me, there are a lot of quite complex things you can actually do with WebSockets and channels, of course, these two combination in Go. Anyways, that's all we need to do to set up our WebSocket endpoint, and of course now I would need to come over here and set this up. So I need to create a get endpoint. The path would be, I'll just use WS for WebSocket. And then I simply add our handler, event handler like this. And that's all we need to do. So I'm just going to start the server one more time and we can test this out on the browser. Let's give this a couple of seconds and then it should come up. Okay, now this is up. And now I'm just going to head over to the browser to show you what this would look like. So right now we are in the browser, and at this website, it's called WebSocket King. You can, of course, use this to test your WebSocket's endpoints to more or less monitor the behavior and everything. And of course, you can also maybe just add a simple HTML file with some WebSockets connectivity within a script tag, and then you can still do the same. But this is much more handy. You don't have to worry about writing your own script. Anyways, I open a new connection here, and of course, it should always start with WS for WebSocket. If it is HTTPS, then it should be WSS. So, but for now, I'm only going to go to the local host. So that's why I'm leaving mine like this. So 8080, and we go to /v1/miss, and then we go to our WebSocket endpoint. That was what we called it. And now we connect. And now you see our messages being sent from our WebSocket server. So if you see, it's actually 2 seconds interval. So this is 7, 9, the length will be 11, the length will be 13, and then 15, because again, we had 2 seconds interval in between them. And it's actually that simple, pretty straightforward if you ask me. And again, if you're really looking into understanding in detail how this works, I would of course link the older tutorial we already did in the past to bring you up to speed. Anyways, that would be all. That's all we wanted to cover in this series. Of course, in the subsequent videos, we are going to continue from where we left up. I think the next thing we would have to talk about behind after this would, of course, would be dependency management in Go. It's also not going to be a pretty long one, but I will make it as detailed as possible. So, of course, you wouldn't need any other resource to understand dependency management in Go. Anyways, that will be all for now. Thank you, guys, and that will be all. If you are, of course, new to the channel, just go ahead and subscribe, turn on the notification bell. I try as much as I can to publish as much, like minimum of 2 videos every week, to keep you up to date with what's going on our channel. And yeah, so I would quite recommend that you subscribe to stay up to date and be informed whenever we release a new video. Anyways, guys, that will be it for now. Until next time, have a lovely evening and bye bye. Of course, if anything is not clear to you, feel free to leave your comments, your questions, and we'll definitely get back to you as quickly as possible. That will be all for now, guys, and bye bye.